Hi, welcome to DeTech Theory's introductory Java programming course. I'm Bronwyn, and today we're going to be going over the first part of Lesson 8, which is arrays. So what are arrays? An array is an object in the computer's memory which stores a fixed number of values of the same data type. What this means is that when you create an array, you reserve a space in memory to store values of the same data type without having to create several different variables to do the same. So why do we need arrays? Well, it's easier to organize data of the same type or for the same use if we use an array, and it stops us from having to create many variables of the same type or same category, when something like a loop could automatically fill in an array with the necessary variables. We can cover this later. And again, with this organization, it's often easier to debug if we use an array. So there are two types of arrays that you should know for your base level programming skills, and that is one-dimensional arrays and two-dimensional arrays. In this lesson, we will only be covering one-dimensional arrays, which store objects and variables of the same type. 2D arrays, however, have another array in each position of the main array. Again, you don't need to know this now, but we can go over that again later. So there are a couple of ways to declare an array. The basic notion, however, is that you're giving the data type as you would with a normal variable and a reference name, but adding brackets after one or both of these aspects. It's as simple as that. Instantiating means allocating a space in memory. When you instantiate an array, you allocate a definite amount of space in memory for that array, which we show in one of two ways. The first way is that you indicate the size by, again, writing the data type after the keyword new, and including the length of the array, i.e. the number of spots for data, in brackets. You can then assign each spot in the array an individual value, which we, again, will cover further on in this lesson. It's important to note that this can only be done after the variable is already declared as an array. You can also use braces on the right side of the assignment statement with each value listed. The length of this array in this example would be 3 because there are 3 different values stored in the array. So to initialize, we would assign values to each position in the array. We're demonstrating this with ints, but you could use any data type, such as strings. The first way on the left forces us to declare each value for each spot individually. For example, array 1 at index 0 is assigned 23. We would then do this for every index. The second way, on the right, is what we discussed before, where we would declare all the values in a list between braces. Now that we know how to make an array, we need to understand its components. First, we have the index numbers. This works the same way as it does for strings, where the first position is assigned 0. The variable or value stored in each index is known as the element at that index. For example, the element at index 8 is the element stored at index 8. Let's say this array over here was initialized as shown. The size of the array is 10, therefore, as discussed in the previous slide, the index numbers range from 0 to size minus 1, i.e. 9. If we wanted to access the value at index 4, we would write it in this syntax, which will return the value 50. So even though this is index 4, it's the 5th position in the array. It's important to note because we start at index 0. So just some notes about the features of an array. The command .length, it's not a method, but the command .length returns the length of the array in much the same way as the length method does for strings. You will notice, however, that the length command for an array does not have parentheses because it is not a method. You will receive an error if you try to use parentheses. Additionally, you cannot simply print an array as they are printed element by element. I recommend you try printing an array in your IDE or compiler to see what it looks like when you try. So now we know the structure of an array, but let's really delve into what is stored in an array through an example. First, we decide what data type we want to use. In this case, we want an int array. We go to declare a new array up here. Then we decide how long the array needs to be. In this case, we want it to be 5 elements long. We then declare and initialize the array and finally set each element to our desired values. Here you can see we also print the length of the array. As you probably remember from our last lesson, which if you haven't checked it out, you definitely should. It's about loops, which are an essential part of Java programming. But loops help us to run the same or similar conditions multiple times without having to write it over and over again. Doing so would make the code extremely long, and that would be very tedious and difficult to go through. For example, if you wanted to print something 1,000 times, instead of writing a print statement of 1,000 times, it would be beneficial to simply put one print statement inside a loop that runs 1,000 times. This drastically reduces the number of lines of code needed to execute this command. This might be helpful if we wanted to increment each element by 1, or assign each element a new value. It would be a waste of time and memory if we had to manually change this kind of data for a 50-element array. However, a loop achieves the same job in a couple of lines of code. The general syntax we use to access each element sequentially is for int variable I assigned 0. This is also the first index of an array, until I is the length of the array, which would be 1 more than the last index. Iterate the loop, incrementing I by 1 each time. A for each loop is also called an enhanced for loop. This is another way to access elements sequentially in an array. The syntax is for each integer in array name, then the body of code. What is happening here that we can't see is that the new variable I is temporarily assigned the value of the element at the relevant index. For example, at index 0, I is assigned the value 1. This element is then incremented and reassigned to the original position in the array. Because we incremented the value at 1, the index of array name at 0 is now 2. So that's all we're going to cover in today's lesson. I hope you enjoyed it, and I hope you learned something, and I will see you next time. Thank you so much.